Welcome to Data Skeptic and our new series on natural language processing. I'm Kyle and I'll be your host on this journey, but along the way I'll introduce you to a few of my supporting cast members. Let's start with the parrot Yoshi. Yoshi is a lilac-crowned Amazon, a species known for their ability to mimic human speech. Oh, that's very sweet. I love you too. But I'm under no illusion that Yoshi really knows what that means. It's just mimicry, really. Although her speech isn't just mimicry. In case you couldn't make that out, what she's saying is, go on. She says that when she wants to be moved. For example, at night when she wants to go to bed. We start hearing, go on, go on, go on, with more and more insistence until we help her go to her bedroom. Yes, the bird has her own bedroom. That's how we roll at Data Skeptic. We didn't mean to teach her the go on phrase. It was an accident. Without realizing it, I guess I had been saying that before picking her up. So put yourself in her shoes. An animal who stands on perches most of the day, moved around by human beings. Frankly, rather unpredictably, really. Sure, we have a sort of a routine, but I take for granted that she doesn't know English, and when I tell Linda, hey, I'm going to go to the bookstore or something like that, the bird doesn't know what that means. But on her own, she pieced together that every time I make this sound that sounds like, go on, she knows she's about to be picked up and moved. And after a while, not only did she notice this correlation, but she started saying it. At first, we couldn't tell what she was saying, until one day I heard my sister tell my niece to go on, and then suddenly it all came together. It's neat that she says this. It's not just parroting a sound. She has some underlying understanding of what that phrase means. She conveys her wants and her needs when she says it, and we in turn warn her if we're about to move her from one perch to another, like when I bring her to the office with me some mornings. So do Yoshi and I share a language? I suppose that's debatable. There are computer languages, regular expressions, invented languages, and a whole slew of other things we might call languages. In fact, the original composition you're hearing right now is from composer David Greiman. This music, our new theme song in fact, can be said to have a language of sorts. The chords you're hearing are G7, F7, and D7. In fact, it wasn't that long ago that seventh chords like these were considered discordant and not part of music. But that all changed, it evolved. And what chords are allowed to follow what other chords, or at least the propensity for one chord to follow another, is indeed a sort of a language. Some combinations aren't allowed, while others are. But Data Skeptic isn't really about music or biology. Much like language, it's sort of evolutionary. Language evolves. This is a show about data. And in our current incarnation, we're a show about the ways in which machines are able to process so-called natural languages. Those languages that human beings invented, or maybe it would be more appropriate to say that emerged from human societies without centralized design. You know, human children are remarkable in their ability to learn language without any formal real training. There are some who would argue our brains are actually pre-wired for it. Yet, as naturally as we may take to natural language, we struggle to create machines that are able to understand, generate, and process natural language. In this series, we're going to use the phrase natural language processing, or NLP, to describe the collection of techniques used for all things related to language, computationally speaking. So let's discuss a few biases of the show. Longtime listeners of Data Skeptic should be aware. Coming out on top are fields like computer science, statistics, machine learning, artificial intelligence, information theory, maybe economics a little bit, and so on. Notice I didn't say linguistics. I'm reminded of a famous quote from Frederick Jelinek. He said, "Every time I fire a linguist, the performance of the speech recognizer goes up." Frederick was the head of the Center for Language and Speech Processing at Johns Hopkins University for 17 years. So if you want to learn about Chomsky, this is not the podcast for you. If anything, I might possibly say some offensive things to people in linguistics or who study languages or things like that. Because frankly, there's no reason to pretend anymore. Computer science wins. Machines are, arguably capable, in a great variety of language tasks. And that list of tasks they're good at is growing by the day. And that growth is driven by research into machine learning, not into linguistics. Now, to be fair, it's really infeasible to ascribe credit to large advances in science and technology. If we were to say, what is the state of the art in machine translation and how do we allocate the contribution from computer science versus linguistics versus 18 other fields, there's no good methodology for doing that. But the point I'm making here is all of the major advancements, the impressive advancements that have come in recent years in the ability for machines to process language, predominantly those come from the machine learning community. And while those researchers might be inspired by aspects of linguistics has not been the driving force forward. The profound breakthroughs in natural language processing are due to advancements in statistical learning, in machine learning, in the unreasonable effectiveness of large data, and also, it's the story of deep learning. I expect most listeners will remember that language wasn't always something computers were good at. There was a time when a computer's ability to do anything at all with language was laughable at best. And despite those early challenges, research seems to have hit a point of inflection at some point in the near past. And data has a lot to do with that point of inflection. So for the foreseeable future on Data Skeptic, we'll be discussing advancements in the field of NLP, the research that drives it, and the people that push it forward. I don't know that our parrot Yoshi will be on every episode. Much as I love her, she has a limited vocabulary. And a lot of her communication is nonverbal and a bit physical and things like that. And although I've explained it to her many times, I'm not convinced she really understands the halting problem yet. My other co-host on this journey is my wife, Linda. Let's meet her now.
Hi, I'm Linda. I don't know. What do you want me to say, I guess? Co-host. I guess I could say co-host. I'm Linda, the co-host. Anything else you want me to say? Basically, I'm kind of Kyle's sounding board where we talk about topics and I ask questions. Since I went to school and majored and have a different experience, I think we like to think that I ask questions that maybe the general population might ask.
Yeah, but your background's not untechnical.
My background right now, I am a project manager. So I work in tech with various tech companies on really making technical or digital products happen, but also managing people and working on large teams cross functionally. So whenever there's a large project that touches every department, it might take a lot of time or there's a lot of money or a lot of risk on the line. I work with companies to really help streamline this process and make sure that the resources like time, money, energy, people are actually being put to use.
Do you have a general sense, because it's a very umbrella term, do you have a sense of what natural language processing entails?
Not really. What does it mean? Who's processing it? What is it doing?
Well, it's definitely a computer that's processing it. At least that's the interesting part. I guess the reason it's a vague term is because it's used in a robust number of ways. For example, machine translation is a good example, taking one document in a certain language and getting it to another. Have you had any experience with machine-based translation?
Well, when we went abroad, sometimes I would use it, but it wasn't very helpful in real time.
Yeah, you're right. I mean, translation's interesting, and we're going to do a whole show on it later in this season, so people should just stay tuned for that. It's still in the works, and there's a lot to be said because translation has evolved very quickly in the last couple of years. And I think the problem you're talking about might be more about user interface design than it is about the algorithms. I think the technology for translation might be there, it's just a little awkward, you know?
I mean, it just, yeah, maybe. Maybe there's a better way to use it. I don't know.
Time will tell. Something a little bit closer to the classic babblefish. Do you know about the babblefish from Hitchhiker's Guide?
No, tell me.
Oh, you stick this fish in your ear, this babblefish, and it's a universal translator, so you're able to talk to any alien species.
Oh, is that why a long time ago there was a translating engine called Babelfish? Because I was like, what is Babelfish?
Yeah, it comes from Douglas Adams.
Oh, everyone's like Babelfish. I was like, what an odd name for a translating engine.
Here's another task NLP people are interested in, topic modeling, that you could take a collection of documents and determine what are the topics they cover.
Yeah, I mean, that might be helpful on a project management level because sometimes we try to look at large amounts of data and figure out what's useful or not.
If your data comes in the form of unstructured text, then maybe topic modeling could be helpful for you. How about sentiment analysis? Are you familiar with that concept?
What does it mean? Does it mean like if you're happy about something or sad?
Yeah, you're along the right lines. It takes in some text that you give it, like English text for us, I guess. And what it's going to do is kind of analyze that sentence and try and determine what is the sentiment. Is it, in a simple case, positive, negative, or neutral? But there's a lot of APIs and algorithms out there that do fancier things like different emotions or split emotions or detecting sarcasm or stuff like that.
Okay, so why do you bring it up?
Because it is one of the sort of classic problems in NLP that people are working on. Another classic one is NER, name entity recognition. I think that's a well-named technique. Do you have an understanding of what it is from its name alone?
Does it mean recognizing something?
For sure. What might it recognize?
Its name.
Well, name an entity. Yeah, so what you might get as the result of an NER algorithm is, let's say, all the proper names that are in there and even the places or brands or, proper nouns and stuff that are present.
Great. So what's the potential? Why do people want this?
Well, we use this in our chatbot a little bit, actually, where we'll run NER on a sentence that a user has typed. So if they said, like, I'd like to know the movie times for such and such movie on Wednesday. Now, I mean, we don't parse movie data like that, but there are chatbots that do this. What you'd want to pull out of that is that they want movie times. That's their intent. That Wednesday is the date they want it. And I probably should have said a zip code or a film title. If I had said those things, it would be to identify those explicit items like title of film and exactly what it is.
So this is probably used very commonly, huh? Like, what about when you try to go those phone trees and it's a message that says, say yes to go here, say no to go here. Is it similar?
Yeah, I'm more of a push to do that kind of guy, but you're right. We could call some of that natural language processing. That is essentially, at least the way most of those systems work, is they do speech to text, which when I say NLP, I really mean text. So the kind of like speech signal processing side of it where we get the audio and we convert it to text, I think of that as a little bit separate problem, but I'm sure someone out there is shaking their fist at me right now saying that's also NLP, and that's a fine perspective. But I think most of those systems, like I said, they convert the audio to text and then they process the text. So this would be a great place then to do NER or just more simply some matching. Like, did they say help or did they say continue or operator or whatever?
Yeah, because I find when I get to those, I try not to use complete sentences.
Yeah, you have to kind of talk in this special language, right? It's not natural language, is it?
I've heard people say you're supposed to talk back similar to the way it's talking to you so that it can understand you.
A little bit tit for tat, I see. Okay. How do you talk to your phone when you use the voice features?
Well, I say very clearly, like, hello, Google.
Oh, you might have just upset a bunch of people if that clicked their phones in the room or something like that. Let's just say hello to me. The other podcasts who talk, I listen to some technology podcasts and people have problems with this stuff. Actually, funny aside, I once was driving and I got stuck in a real life infinite loop. This is the craziest thing that happened to me. I have an Android phone and on the podcast, someone said, okay, G, and my phone clicked on and it was like, oh, you want me to respond because we're going through the car stereo? But then I didn't say anything, so it timed out. However, the podcast app I use, if it gets interrupted, it backs up 10 seconds. so that, like, you don't miss whatever was clipped. So it went back to before the guy said OKG, and then it happened again. So like I was stuck until I messed with my phone. I was going to be in an infinite loop.
Wow. I I feel
So be
like that's
careful.
the plot of a bad movie. So yeah.
You make a whole movie out of that? Wow, you should write for Saturday Night Live. Anyway, so there's been, in my mind, there's a dichotomy that I want to discuss with you today to wrap up our conversation, and it's the different techniques one might use for doing natural language processing. A lot of the techniques I was raised on were just starting to use some machine learning. Most of it was based on statistical techniques, like counting up the word frequencies and things like that. How many times does the word parrot appear in a document? Tells you a little something about that document. Or realistically, when you compare how many times it says it there to how many times it says it in common documents, because obviously every document in the world probably has the word the in it, and the number of times it has the is not so relevant. But for these more significant words, yeah, the frequency tells us something.
Frequency tells you something. Sure. I mean, definitely frequency tells you something.
Yeah, very early primitive search engines. One thing they would do to determine, what page to send you to when you put in a certain keyword was to look for how many times that word appeared on the page. Obviously, no one does exactly that today anymore because that's a very crude system. Do you know how people manipulated it?
How? They would just keep repeating the same word over and over?
Yeah, it was called keyword stuffing. So, if you wanted to be at the top of the page for credit card processing, you would just write credit card processing 10,000 times on your page. And then, maybe your competitor wrote it 10,001 times, and that's how they got into first place or something like that.
Well, I'm sure that was back in the day of the older internet.
So that's obviously a big problem, not just because you can kind of hack it or trick that algorithm, but because it's a pretty crude way of doing things, right? The number of times a word is on the page, it seems like an intuitively good idea, but you can only take it so far.
Take repeating a word so far?
Yeah.
Well, you're just repeating it. I mean,
Well, I
that
guess
is
let's take a real world use case. Let's say we wanted to grade students' English essays with an algorithm. First of all, do you think that that's a believable thing one could do?
anything is believable.
Oh, I'm glad you said that. I thought you were going to fight with me on this because a lot of people, a lot of like non-computer people or non-technical people will be like, "Oh no, a computer could never grade an essay," which is total BS, right?
Well, can grade it. Whether they grade it well, I don't know. Depends what
Oh, well,
metrics.
yeah,
You didn't
of
say
course. Yes.
well.
All right. They can grade it at or above human level accuracy.
At or above. Well, they would probably be very consistent. Let's be honest there.
Well, that's one strength of algorithms. Yeah, they'll be more consistent. One of the metrics you'd want to use if you were doing this for real is to get multiple people to grade an essay and look at the inter-reviewer agreeability. How many people gave it a B. If everybody gave it a B, that sounds like a B. But if you got an A and a B and a C across 3 reviewers, what do?
Average them.
Good answer. Yeah, that's probably the right way to go. Do you think if we just counted how many times someone used words, would that be a good way that by those methods we could come up with a great grade for that person?
Well, a grade?
Yeah.
Well, okay. First, we have to set up what's this testing? What was the essay about? And then I'll answer your
Okay.
question.
All right. So you have to write an essay about Charles Babbage, his life and his contributions.
Okay. Why? What's the purpose of this essay?
That's the class assignment.
But usually there's a purpose. So what's the purpose? That's the assignment, but there's the purpose is not the assignment.
To help people better appreciate the analytical engine and Babbage's contributions to science and history.
Okay. Great.
So, maybe we could look at how many times did they mention Charles Babbage by name and how many times did they use the word the or how many times did they, use different frequencies of words. After all, like probably should have a certain variety of words so you could see how robust is this person's vocabulary and maybe using more than 200 unique words gets you an A, 150 to 199 gets you a B, some system like that. What do you think?
I mean, sure, but eventually I think the kids or whoever's writing this, they will eventually catch on and be like, great, just stuff 30 vocabulary words, mention the 10 times, and then repeat the guy's name 20 times.
You're right. So they could kind of hack that system a little bit because it's not a good evaluation metric. But I don't think we could even get it out of the gates. I don't think we would get anywhere near human performance level with those crude techniques because the key thing that's missing there is context.
Context. Yeah, that's a good word. I love it. Yes, context is missing.
So a lot of these classical statistical techniques, they use something called the bag of words. And it's just sort of like put all the words into a soup bowl and mix them up. Don't worry about the order. Let's just look at frequency of words or the position of words and just very simple structures like that that are easy to parse.
Okay.
One of the great challenges in a lot of natural language processing is the word not, N-O-T. Do you have a guess as to why?
The challenges? Well, does it mean it's a
Yeah.
positive or a negative, or what are you saying? I guess.
The presence of that word, the very existence of that word makes the task of an NLP researcher significantly more difficult.
Okay, well, tell me why.
Well, because not can sort of shift the whole meaning of something. So I could say Charles Babbage was a great mathematician, and maybe that's something that would get you an A or a B paper. If you say Charles Babbage was not a great mathematician, well, I mean, I guess you could take that position, but probably that's not the correct position. That sounds like a D or an F of someone who's either hasn't done the assignment, doesn't know who Charles Babbage was, or maybe they're trying to make a point, like they're going to be clever and say he was not a great mathematician because of reasons X, Y, and Z, and they want to promote discussion. But either way, just counting the presence of the word not doesn't tell you anything. Just counting words doesn't tell you how those words affect each other, like what did not negate, and what is the meaning of that negation.
Right. Okay, yeah. That's complicated in English.
This bag of words stuff, I'm going to rag on it a lot throughout our series and talk about how terrible bag of words is as a very crude, blunt instrumentation for doing anything with language. However, I want to take one footnote here and point to people to this moment in case I get a lot of flack on this. There are many good reasons why these crude techniques can get the job done. Spelling checking and grammar checking are great examples of that. You don't really need fancy algorithms for those. People have solved those problems in sort of linguistical ways or just with simple frequency counting kind of ways. Markov chains are another tool. So, depending on what you're trying to do, there are plenty of basic methodologies for, maybe giving you what you need. If you're going to look like some sort of linguistical analysis of how, I don't know, how Creoles develop. You know what a Creole is?
No. How do you spell it?
Creole.
OLE, like
Yes.
Creole, like New Orleans Creole? Oh.
Well, yeah. It's no surprise you thought of New Orleans because it's famous for having I think, a French and American Creole. So the dictionary definition here is a mother tongue formed from the contact of two languages through an earlier pidgin stage.
Pigeon stage. What's a pigeon stage?
Yeah, pidgin is like a basic form of a language. Think of it like kind of like caveman talk, where you just have like one word, like ouch, hungry, wolf. You just have sort of like the basic words, and it's blunt. But it's the starting point where people can exchange information, even though there's no structure, like nouns and verbs and past tense and all that kind of stuff. Pidgin is just this very crude caveman, cavewoman like language.
Hmm. Okay.
So you can imagine put some people together on like an island without translators who speak two different languages. They're going to have to learn to communicate, and they're going to start with just like what are the important words like food, shelter, rain, danger, fire, They'll each learn the words from the respective languages. I'll learn the French word and the French person will learn the English word, and we'll start communicating with just a basic shared vocabulary. And maybe sometimes, for I don't know how it'll happen, but there'll be a natural way in which people will kind of merge the words or pick one word for, certain things. Like, maybe one of the cultures is more into cooking, so their words play more into cooking, and the other culture is more into music, so the musical words are from them. But a language or a tongue that kind of is the merger of two other languages. That's a
Okay.
Creole.
Okay. So why are we on Creole now?
So I was talking about the statistical techniques and like could bag of words be useful and stuff like that. Like maybe if you were going to study the emergence of Creole languages and you were going to get old books and look at when words first appeared and stuff like that, there are these basic statistical techniques that might do exactly what you need for that kind of research. Interesting linguistical stuff can go on. But for the type of NLP I'm interested in, which is getting computers to do very advanced NLP tasks, it's become rather abundantly clear that the statistical methods are insufficient. They're not enough. And we're going to need, or at least the one successful path that we found so far, there could be other paths, but the one that's winning right now is using these deep neural networks as the approach to language understanding and processing.
Okay.
So many of our future episodes are going to go into those. I'm not going to cover as much history as you might think because there's so much relevant contemporary research going on. It's going to be enough just to cover all that.
Okay, well, I'm gonna keep asking, but I hear you.
The Gartner Data and Analytics Summit is taking place in Orlando, Florida, March 18th through 21st. So who is this conference for? Well, really, it's for the full range of data professionals. Obviously, my personal bias is for the analytics and business intelligence professionals. Data scientists, BI people, real practitioners. But this is also a great conference for people in information management. Those of you working on things like master data management and data governance. People on the CIO track. It's also a great event for senior IT people and business leads. And of course, for chief data officers. In fact, if you're a CDO, you need to get over to gartnerevents.com/dataskeptic and find out about the CDO Summit. There's some exclusive events for CDOs. And whether you're a chief data officer, you're on the chief data officer track, or you're just data curious, there's certain to be something in the 8 tracks they have that's of interest to you. Now, I don't have time to cover all those tracks. There's a ton of content. Let's do some of my favorites. The first would be Track A, Data Science and Machine Learning, Breaking Through the Hype. Oh, and here's an interesting workshop, Paths to Becoming Your Organization's AI Expert or Machine Learning Architect. I know there are many listeners in growth roles right now. Are you at a company that's trying to figure things out? Find out how you can be a leader in your organization. If you're at an org already sophisticated, maybe Track C, Data and Analytics, the way ahead, is where you want to spend your time. There are talks covering topics like Internet of Things, virtual reality, and augmented reality. Whether you're looking to explore the future of your career, or you're interested in getting your company to send you to get the wisdom that's available at this conference, check out the Gartner Data and Analytics Summit and see if it's the right event for you. Orlando, Florida, March 18th through 21st. More information at gartnerevents.com/dataskeptic. That's gartnerevents.com/dataskeptic. There's one element I wanted to emphasize a little bit. The vast majority of the research I'm familiar with in NLP deals with the English language. It's the only language I speak, and it's the language we publish our podcast in. So naturally, we're going to have a bias. But I'm well aware that English is not the only language spoken widely on the planet. I'm not even 100% sure if it's the most popular, depending on how you measure it. And interestingly, a lot of the most advanced methods and algorithms and things like that that are coming out seem to be invariant to the language. That is to say, if you have a great new algorithm, it seems to be the case that when chunked appropriately, that algorithm will work equally well on English as it does on many other languages. Now, naturally, you might need a large amount of training data comparable across languages, but it's not that support vector machines are good for Japanese and random forest is great for German and logistic regression is great for French. No. If anything, what machine learning seems to be implying is that the same techniques are widely appropriate. We might train a deep neural network to do some sort of language task. And of course, the parameters of that network will be different from language to language, even from run to run. But it seems to be the case that we won't need a specialized architecture for individual languages, which is fascinating. But anyway, I am well aware that despite the English bias of this podcast, there are lots of other languages. So I'm going to put in a small effort to try and cover some of the interesting data science work going on in non-English languages. I'm going to put in an effort to cover some of the interesting work going on in non-English languages. And to be perfectly frank, I'm going to need your help with this, listeners. I've lined up a couple of great interviews, But if you know of people doing interesting research related to non-English, please reach out and let me know. We want to share these segments on the show. And to kick that off, our final segment today is with Lucy Park, a Python library aimed at helping people do NLP in the Korean language. I speak with her about her work on the KoNLPy library.
Hi, I'm Lucy Park. I work as a machine learning scientist at Naver Corporation, a search engine company based in South Korea.
Lucy, welcome to the show. We got in touch when I learned about your work on the KoNLPy library. For listeners unfamiliar, what is KoNLPy?
In short, KoNLPy aims to be similar to NLTK for the Korean language, where NLTK is a Python-based toolkit, as everybody knows, for NLP in various languages. It includes several NLP-related tools from basic pprint modules to data downloaders and morphological analyzers that were previously developed by various people in various languages. So KoNLPy aims to be a simple-to-use, well-documented package that includes many of the pre-existing libraries in a clean and unified interface. So this might be a cliche, but you can say that it's a package that aims to stand upon the shoulders of giants.
And for listeners who might be unfamiliar, can you give us a definition of what a morphological analyzer does?
The Korean language, actually many languages are consisted of morphemes. Morphemes are a very important part of the language. So what we do when we do morphological analysis is that we try to split up words, which can be split with spaces, and then we try to split up those words into several smaller segments, which are called morphemes.
So is that somewhat analogous to a token in a lot of other contexts?
Yes, I think you can say there are tokens.
And how did you first become involved in the project?
I encountered a project that involved Korean text during my PhD studies. I found that there were indeed several open source implementations regarding the Korean language, but most of them were binaries and lacked documentation. So when I was attempting to compare their performance, it was quite difficult. So what I decided was that I should develop a package for my personal use. And then I ended up open sourcing it for some reason and then presenting it at PyCon Korea. And so that was the beginning. But at first, I thought it was nice to include many of the features in NLTK itself. But this was not possible since many of the pre existing libraries were licensed in GPL.
Well, please tell me a little bit about your PhD and how the library helped with it.
Actually, the project was a text mining project. And so I had a whole bunch of reviews from customers, and I kind of wanted to extract the needs of these customers. But in order to do that, we have to get the basic elements of the text itself. If it were English, we would like to split with white spaces and get the special tokens removed. But for the Korean language, it gets a bit more complicated because words themselves, when they're divided with spaces, it's not actually enough. Korean is a agglutinative language, as they say, which means many of the part of speech tend to get glued together. For example, if there's a phrase saying Lucy is, then the space in between Lucy and is removed. So this makes word segmentation or morphological analysis an important part of when handling Korean. And so this is the reason why morphological analyzers are a major part of KoNLPy.
Do you have any examples of how other people are using the library?
Yeah, mainly students use KoNLPy for research purposes. And I've also seen startups and sometimes large companies using KoNLPy for in-house experiments when they are attempting to approach the Korean language.
So, with regard to all of the various NLP tasks one might take on leveraging the library, something like, let's say, part of speech tagging, are there any aspects of the Korean language that make it mathematically different from, let's say, NLP in some other language?
I should say basically no. As with other languages, part of speech tagging in the Korean language are mainly done with traditional algorithms such as HMM and CRF, very recently LSTM, CNN, and so on. But sometimes computational linguists do use the characteristics of the Korean language itself, as it would go for many other languages. As I said before, Korean is a agglutinative language. So what they try to do is they try branching either from the left side or branching from the right side and doing a grid search of some sort.
So with regard to the various services the library provides, under the hood, does it do it with more kind of rule-based linguistical systems, or is there some machine learning baked in as well?
I guess some are machine learning based and some attempt to be dictionary based. For example, one of the morphological analyzers included in KoNLPy, which was made from Twitter, is mainly a rule based library. But then some other, for example, KKMA, we call that Kokoma, that one is based on HMM.
So hypothetically, let's say there was a data scientist who had some Korean language documents but doesn't speak Korean. Could the library be useful to them in doing some analysis?
Sure. Korean language is very distinct in that it has its own character set. But other than that, it's just generally very similar to any other language. So I guess why not?
Where's the best place for people to go if they want to get their hands dirty with the library?
I guess KoNLPy.org, or you can also find KoNLPy on GitHub.
Okay, listeners, that's it for our kickoff into natural language processing. In the weeks and months to come, we're going to get into use cases, methodology, of course, and I'll do my best to catch you up on the state of the art. The problem is it's moving rather quickly. As mentioned, if you've got a hint about a great topic or interview related to non-English based natural language processing, we want to include those voices in our show as well. Please visit dataskeptic.com and figure out how to join our Slack channel. From there, give us a recommendation. Or if you just want to share your NLP project, do that as well. Well, all right, everybody. Happy 2019. We'll see you next week.